All right, this is in this lesson we're going to talk about 3/8 unions and sets. Sounds real fancy, and well, because it is, it's super fancy. Unions and sets. Actually, it's unions and intersections of sets. So unions and intersections are a lot like the ands and the ors that we have dealt with before. So looking at this particular part in our notes, um, I guess I would say intersection, they use this upside down U thing right here. That means intersection. And if you think of a Venn diagram, it's like the stuff that they share, this stuff right here in a Venn diagram. So a quick example is if I have set A is 2, 4, 6, 8, and set B is 8, 10, 6, 9. How we, excuse me on that, how we would write this as A intersection B, it would be the stuff that's both in A and B. And if we look at that, it looks like it's 8 and 6. Okay? Now, when they talk about union, that's everything. So A union B would be everything in the two sets. So 2, 4, 6, 8, 9, and 10. That would be the union, if that makes sense. So it's pretty simple, but a lot of people have a hard time with it. Just remember that the symbol U, upside a regular U, is union. This is a lot like or, so it can be in any of the sets. This is a lot like and, which means it's in both sets. Okay, so check this out. If your left pocket you have a quarter, a paper clip, and a key. In your right pocket, you have a penny, a quarter, a pencil, a marble. What is the set that represents the different items in your pocket? So here is my left pocket. I wrote that out. Quarter, paper clip, key. Here is my right pocket. Penny, quarter, pencil, marble. What is the set that represents the different items in your pocket? Different items. So they want us to do L, left pocket, union with right pocket. So all the stuff that I have, which would be a quarter, a paper clip, a key, a penny, a pencil, and a marble. Now, to kind of make it crazy here, what would be the intersection of this? This is extra. What would be the intersection of this? Is there anything that they have in common that's in the left and the right pocket? Looks like it's just the quarter. Okay? So you have a got it. In fact, I think we're going to try to do the got it together. So right sets P and Q below in roster form. So P such that X is a whole number less than 5. So I guess this would be a whole number less than 5. A whole number less than 5 would be 1, 2, 3, 4. Wouldn't it be 1, 2, 3, 4? I guess the question is, do we include 0 there? Do we include 0 in that? 1, 2, 3, 4. Yeah, actually 0 is included, isn't it? So I'm just going to throw that in there. And then Q says y is an even natural number less than 5. So natural, that's the 2, the 4, and that is it. So what is the union of the two sets? Well, that would be 1, 2, 3, 4, and 0. Make sense? Bonus, what would be the intersection of the two? Well, it looks like it'd just be, well, sorry about that. Looks like it would just be the 2 and the 4. Okay? Let's move on and talk about the next problem here. Intersection. So let x be a set such that x is a natural number less than 19, y such that it's an odd integer, z is a multiple of 6. So what this might help me to write this in roster form. I can say x is basically a natural number, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now I know that's a lot of writing, but that's why we use roster form, set builder notation. Y is an odd integer. An odd integer could be like negative. Actually, I'm going to go dot, 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 and be like -3, -1, 1, 3, 5, dot, dot, dot. And let's see about the last one. Z is a multiple of 6. So, multiple of 6, this could be like -12, -6, dot, 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 -12, 6, 12, 18, dot, dot, dot. So it seems like a lot to do it this way, but it is what it is. So what is the intersection of x and z? Well, the intersection of x and z, it looks like it'd just be 6, 12, 18, right? What about the intersection of y and z? Now, the intersection of y and z. Y is odd integers, and z is increments of multiples of 6, which means you can multiply them or divide them by 6. Weird. That is nothing. There is nothing that can be multiplied or divided by 6 and at the same time be an odd integer, because 6 is an even number. Dang, that's deep. Okay, so you have a got it. Why don't you take a moment and do the got it? And I'll see you back here in a sec. Problem number 3. Making a Venn diagram. 3 friends are going camping. The items in each of their backpacks form a set. Which items do all 3 friends have in common? So you can look at this picture and you can see what they all have in common, or you can see that I drew a Venn diagram. In the yellow bag, I have a flashlight, I have some sunglasses, I have some water, a hat, it looks like a map, and a pan. In the red bag, it looks like I have some rope, have a first aid kit, some water, a hat, a map, and a pan. And in the blue bag, looks like I have some water, a hat, a camera, and a first aid kit. Now, if you see how I drew the how this is drawn, you can see that what does both the yellow and the red have in common? That's the pan. See that? Water, hat, and map. Right? But they all 3, which is this part right here, that overlap of the 3 circles, they all have water, hat, and a map. The blue bag has a camera only. Nobody else does. The yellow bag has a flashlight and sunglasses, and the red bag has a rope. So together, it looks like they're pretty much set for a camping trip. You got it. Take a moment, pause the video, and do the guide. I'll see you here in a sec. Problem 4. of 500 commuters polled, some drive to work, some take public transportation, some do both. 200 commuters drive to work and 125 use both types of transportation. How many commuters take public transportation? All right, this is difficult, but if I think of it like this, if I think of it as a Venn diagram, this is my drivers, and this is my public transportation. Now, 500 commuters polled, so the total amount in both circles is going to be 500. Some drive to work, some take public transportation, some do both. 200 commuters drive to work. So I'm going to put 200 right here, right? So the whole thing, right? 125 use both types. So 200 go there, right? So actually, let me back this up. So 200 go there, but 125 you've used both. So here's the thing. 125 need to go here. And if 125 go there, then 75 right here drive because 75 and 125 make up the total 200. So if there's a grand total of 500 commuters, right? And we take away the 75, actually, yeah, we take away the 75. Actually, correction. We don't take away the 75. We'll take away the 200. Okay, we'll take away 200. It leaves us with 300. It'd be really easy to say, oh, well, 300 go in here. But that's not true because of that 300 that take the public transportation, 125 do both. So if I take 125 away from 300, if I take 125 away from 300, that, excuse me, if I take 300 plus 125, that leaves me with 425 people. Now, how does this make sense? Okay, if I take the 425 people, hold on, I goose something up. Um, so let's see, the number of computers who only drive is 75 because the whole thing is 200. Okay, so there's 300 left. Oh yeah, okay, so what's 300 minus 125? Well, the total is 425, so there's 300. Yeah, there's 300 in there. Yeah, because the whole is 425 plus. Yeah, that's all right. That makes sense. So this is 300 who just take the public transportation. All right. So this is a little sketchy. I apologize for that, but hopefully you get it. All right. Let's talk a little bit about the. Let's talk about the next problem. What are your solutions of the absolute value of 2x minus 1 is less than 3? Write the solutions as either the union or the intersection. So we've done this before. So first thing is that less than 3 an example of the and or the or? And that's an example of the and. So we're going to go negative 3 is less than 2x minus 1 is less than 3. Then we add 1 and we add 1. And we get negative 2 is less than 2x is less than 4. Then we divide all three spots by 2. So you get negative 1 is less than x is less than 2. That's what that looks like. But if we had to do this as a union or an intersection, this is like and. So that means it's a lot like the intersection. So using set builder notation, I could say that curly bracket x such that x is greater than negative 1 and at the same time x such that x is less than 2. This is what they use in the big old fancy math books that are at the college level, but I know this video is a little bit long, but you have a couple days to watch it, and I look forward to seeing you in class, and may the force be with you.